Okay, welcome everyone to Robot Builders Night Virtual for September 23rd, 2025. And we're going to start off with DPRG news, and like usual, and then we have a queue going, and then we'll move to open mic. So DPRG news, we had fun gathering. About 10 people showed up for the robot power lunch last Sunday at Ford Garage, and that was fun. And yeah, a couple of new people, including Dave Dubay, who's here tonight, and he volunteered to give us a tour. So we're going to do that first up in the queue. This Saturday, September the 27th, we have the September monthly meeting at 10 a.m. at the Dallas Makerspace. Kareem will be showing us part 2 or the continuation of his By Your Command demo, commanding robots to move and describe what they see using an LLM for real-time interpretation, understanding of commands, and spoken responses. So that'll be the full-blown demo that wasn't fully working last month, and then so we've got a double header this Saturday. After that, I'll give a talk on Git and GitHub it's going to start off for beginners, kind of how to get started, and then I'm going to try and deliver some value for people who've been using it and are familiar with Git, and give some advanced use cases. And but I'm not going to go into branching, which is like a big topic. I figure I'll save that for part 2 next month. So that's DPRG news. Anything else I should mention is coming up? We decided, we noted that the Robo Columbus will be on November the 22nd, in place of the usual meeting. And that's the DPRG news.
This is the robot I'm working on for the Robo Columbus. So
nice. Yeah, our mini bot is about that same size, so that's why I was very interested. That's awesome.
Yeah. So you can see it sort of taped together and everything right now, but the idea is to well, I think I'm going to quickly securely mount this stuff, but right now I don't have the cover for it. So, but you can see it has all the sensors on it. Like the round one is the LiDAR, then it has a GPS and an IMU and the camera in the front. And
stick with the masking tape. It's colorful.
I guess one question I do have, which I did see on a couple of the videos from, I guess, 2023 and 2024, y'all mentioned, or at least it was kind of mentioned, that there was like an RTK base station. What's the we don't have an RTK sensor, but we're interested in getting one this year. What do we need to connect to y'all's? Is it, I know it's like some Wi-Fi or LTE base. I know you need to go to the network.
It'll be published through RTK to go.
Okay, sounds good. That's the free one, right?
Yep.
Okay, I got it.
So I'm going to put all the electronics inside of the cabin of the shell that came with that remote control car, and then the camera would look out the front window, and I put the LiDAR on the top like a Wemo, and the GPS on top. And so when I'm finished, it's going to be inside of here. So I have another wooden platform that's designed just to fit into here. I took out the upholstery and stuff they had in there, and the driver and the steering wheel, and so eventually I'm going to move all those components onto here, and then it'll just be part of this thing, and then this would go on and clip onto the body. So So that's
So-
my.
You weren't going to use the Corinthian leather upholstery?
Yeah.
That is an awesome robot, Mike.
Yeah.
Yeah, it's really great, Mike. That's a great example too to show the students. Can you bring that Saturday? They'd love to see that.
I'm going to try to. Yeah. Yeah. The pill bottles don't quite make it, but it's sort of like, okay. And so on our lunch last Sunday, I came up with a question of, here's my time of flight sensors, and so you can see that they have
Lenses.
I got 3 of them, and each of them have 64 sensors in them, and it has a 45-degree angle, up and down, left and right. And so this gives me 135 field of view with a 45-degree up and down. So it gets a pretty good range. It gives me a lot of sensitivity to low obstacles that are low to the ground, like boulders that aren't tall enough to be sensed by the LiDAR and stuff. And so I was talking yesterday or last Sunday about how am I going to do this plexiglass? So I have here on my like the sensor here, I have the plexiglass here, and I was wondering, does it work well with the plexiglass on it? And so I just cut some pieces of plexiglass. I was talking about people, sort of agonizing, how do I cut the plexiglass? And I eventually came up with the way to do it is to use my paper cutter. Those paper cutters.
The guillotine.
Yeah, I get the guillotine ones, and it did a really good job. You can see it cut a good job on it. And right now, I was wondering, do they distort the signal or have reflections and crosstalk? And so I taped them on there, and it seemed to work just like without the plexiglass.
Wow.
So I do have a way to protect the sensors from the elements now. I always worried about taking this outside and getting dirt inside of those sensors. You can see the sensor right in the middle with the red dot on the top. I think that's the receiver, and the bottom one is the laser transmitter. And so it's like, okay, how do I protect those? Because they're supposed to be real sensitive. You don't want to get dirt on them and debris. And then this was the back side of it. You can see I got the cable that goes to the board, and the back side is I just soldered it on to the holes of those boards, and then made a cable harness to go to my sensor board to collect the data and send it to the Raspberry Pi. So and this
What
is just a prototype.
using in those? Is it SPI or I2C or UART or?
It's I2C. Yeah.
Oh, okay.
There's one I2C, and I change the address on all of them and send it over this one I2C connection at a megabit per second. And then I had so this plexiglass is working really good. And so I'm going to redesign. Well, this is just a prototype just to mount them to see how it works. And I'll be making a fully enclosed one that'll protect them all from the elements. And I'm going to get a way to mount this window into a little insert and then screw the windows on. So it'll be really robust. It can bang into stuff and not have any problems. So
you're not getting any issues with reflection off the back surface?
I haven't seen any. I mean, I mounted the sensor so it basically touches the plexiglass. I mean, it's not plexiglass, it's the polycarbonate. So I did careful measurements, and when like the sensors, you can sort of see on here the screws that hold the sensors on. We'll have an inset into that 3D printed holder, and I measured it so that the top of the sensor is at the same level as the outside surface. And so when I put the plexiglass on it, there was basically no gap between it and the sensor. And the sensor manufacturer says to make sure there's no, as small a gap as possible. So, and if you can't not have a gap, if you have a gap, then you have to do some shading to keep this light from reflecting from one side to another. And that's what I was getting all in a knot about. But it looks like it works in the house. It should work outside. So I'm going to find out.
Awesome.
And another thing I did with that in-person meeting, not called a meeting, but the luncheon, was I had this idea. I wanted to be able to get files on and off of my robots. One of the files was like the ROS bag that collects all the sensor data and everything, so that you can play it back and understand what happened or what's going on to make some improvements. And so I was going, and another application is to do the GPS coordinates, make a file. I'm going to do it in JSON format, make a file, and then have the code read that to figure out where the coordinates are. And that way, I'm not changing the code itself. I'm just giving it a file to read. And then my idea was, okay, I need to get the USB drive on and off my robot. And so I worked for a long time, hours, trying to figure out how to get Ubuntu to auto mount the flash drive on the fly, where you pull it out and plug it in. Windows and a lot of stuff does it automatically, but I couldn't figure out how to get Ubuntu to do it. It wanted you to type in a password to mount it. And it's like, that's not good. But then during the luncheon, I realized, hey, it's going to be inside that Jeep chassis, and there's no way to get flash drive in and out of USB slots. So I got to nix that whole idea, and I just put a Samba server on my Pi, and it works really good. I'm really happy to use that. It looks like it's going to do the job I'm going to have to do to get the files on and off. And another thing I've been working on is I'm trying to drive it in my house autonomously to go find a cone in my bedroom around the bed, around the corner of the bed. And it seems to get stuck. So I'm trying to work on the ROS navigation software, and I'm trying to, how can I unstick it? It seems like the recovery programs that are built into it just aren't working right, and I'm trying to figure out how to tune them up. And one thing that in the recovery program that works really good on a Roomba is to spin around when it gets in a tight situation, spin around and go the other way and back up and just zigzag back and forth. And but the car robot like that doesn't spin, So how do you make a car spin? So I was thinking, oh well, when you're parallel parking, you're just going little movements like that to sort of get into the spot. So I figured I got to figure out how to put that into the navigation code. Like when it gets stuck somewhere and it fails, it says, okay, well, do this movement to do something to get you in a different starting point, so that maybe the navigator can figure it out.
Maybe a 20-point turn, back forward.
Something like that. Yeah. Yeah. So I realized at that point I need to have sensors on the front and the back. So I'll put a set of these on the front and a set of them on the back, and that'll give me the ability to, like the navigation software, it's really conservative in terms of trying to keep away from obstacles. And so it's like, okay, well, I'll probably have to get out of the navigation software and do my own using these sensors. And and to try to get out of a stuck spot. Because like the last few years at the Robo Columbus, I've noticed that some of the robots get stuck, and they have a hard time unsticking themselves if they get tangled up in a bush or something. And so I'm trying to figure out how do I come up with the recovery program to say, okay, I'm stuck in a situation and I got to get out, because if you're stuck and you're over, because you can't manually do anything. It has to do it all autonomously. So that's what I was sort of working on today is trying to figure out how to do a behavioral tree. And then I was going, I can't really get my head around behavioral trees. So maybe I'll just do it with state machines. Like if the navigator behavioral tree gets stuck and it says, I give up. Well, I'll just do a little manual coding to move it around and try to get it unstuck. So that's sort of what I'm doing. All these little rabbit holes to get stuck down, to get trapped in. But I'm really happy about the polycarbonate working. So
it's a big project, Mike, and there's a lot of different aspects to it. So it's pretty cool.
Yeah, you guys have been working on them, so this is my first one. For the other guys, people work on the robots and then bring them back the next year, and hopefully they're better, and the next year they're even better. So to be the first year guy, you're usually sort of like, I hope this does okay. I hope I get 1 point. Yeah. So I'm hoping for more than 1 point. Yeah. I'm hoping for everything. So
is this your first year?
Huh?
Is this your first year?
I've never had a outdoor robot.
Huh.
This is my first outdoor robot. I've done 2 or 3 indoor robots, but I haven't done an outdoor robot. And I want to make a sumo robot too. And so I can do all 3 scales, like the tiny one, the indoor one, and then the outdoor one. So, yeah.
Awesome.
All right, thanks.
Thanks, Mike. Let's see. I think we only, that was the end of the queue. So let's throw it open for open mic. Whatever anyone's run across that's new or that they've been like up to, engaged in.
Yeah, I took a look on Copilot and just asked it, what are the best plastics? And it looks like optical grade PMMA, and they have in parentheses acrylic. There's a cyclic olefin copolymer or COC plastic, polycarbonate, and it looks like another one is called either ZNX or ZNOR. And they have different characteristics, but I think probably one of the most important ones is, is it, transparent for IR, because you don't, you're in the IR range and you don't want to limit, what the little sensors put out or what they can receive back. So
yeah, like the ST Micro, they basically said polycarbonate's great and make it as thin as you can.
Yep.
So,
yeah.
Yeah.
So. Or if you work for, the company that Scott works for, you could probably just say, hey, I need some custom plastics here. Can you make those for me?
Yeah. Well, I'm just happy I can cut it in squares with straight edges. So
that was polycarbonate, and you were able to cut it with like a paper cutter?
Yeah, it's a 1/32 of an inch.
Oh, okay, yeah.
So it's
really
like thick
thin
cardboard, but yeah.
Yeah.
Or cardstock. Yeah.
Yeah. Acrylic, I don't think does well on a guillotine kind of.
No,
I think it would
no.
just
But
shatter.
polycarbonate seemed to have some give to it, so I was pleased.
Mm.
It didn't fracture or splinter or anything. It was just a nice edge.
Wow.
You can also bend it cold at those thin layers. So
Mhm.
up to about a couple of millimeters, you can just force it to up to a 90-degree bend just fine, and it'll hold. Don't need any heat.
Really?
Yep.
Mm. I thought maybe it would crack.
Yeah, so
Once you get thicker, it will.
this is my sheet here, and so the sheet can bend.
Mm.
If you heat it up, you could probably bend it better, but that's about as much as it wants to bend with just a couple pounds of force. And then I cut the strip off with the paper cutter, and then I just cut another one, little chunks of it off. And so this one bent, this size here can bend like this.
Why don't you sacrifice a little bit for us in a live demonstration right now? Because I'll bet you, just using your thumbs, you could bend it over backwards and put a 90-degree bend in it, cold, without any heat.
Huh?
And it'd be just fine.
Ah.
You want to bend just like the very end of that strip? Are you okay with sacrificing a teeny bit?
How do you do that?
Just start bending it. Just pull it, push it like you would do a thick piece of cardstock, right? You just start folding it, and where it starts to fold the most, you just keep putting pressure.
Let me put it in my vise.
No, you don't need to do it by hand. Well, you could do it by yeah, but yeah, you could do it for vise. That's more, but we can't really see it. Can you see it? But my point is, you can also do it by hand. But yeah, I usually have the robot kids do it by with a vise because they find it a little bit tough.
So are you using it for the same reason? You're just looking for protection for sensors?
We don't usually use it for sensor covers. We usually exactly. And you can with your thumb you can bend it to a full 90 degrees.
Yeah.
And it will hold it.
Yeah. So a little more effort, it could be bent. Yeah.
Yeah, you just got to bend past a little bit, and it's great because now you can create a like L-shaped tab. So if you had the bolt to the flat plate on the bottom, but you wanted a vertical wall, that's one way to accomplish it, right? We use those for mechanical purposes usually as deflectors and connectors and things like that.
But do you use like 32nd of an inch or?
Yeah, you can. That's the one that you can do by hand. You start getting thicker, it's harder, and I'd say at a millimeter or more, you want to start using some heat to soften it. And then if you're really thick, if you're above 3 millimeters, then you're like wanting to do almost a real. You really need to get it up to the glass deflection temperature, or whatever it's called. Transition.
This looks like about at 1 millimeter, so I'd have to do the conversion.
That's a little bit less.
Yeah.
So Mike, where'd you get that?
Amazon.
Oh.
I buy it in 4 by 8 foot sheets from Allied Plastics.
This is like $5 or something. So yeah. So it's RoboSource on Amazon, but yeah.
So I've got a demo I can actually do. I just figured out that might be of interest. So let me see. Let me just pin myself if I can. For everyone. So this is the robot that I showed last week. There's a little bit of a sad story about this. the last week I finished assembling it, and it one of the motors was bad. Like I could touch the magnetic odometry sensor, and it would stop, and touch it again, and it would start. And so I was like, okay, well, maybe I broke the motor.
Is that the maker's pet?
Yeah, this is the maker's pet. So this is the chassis, and the blinky light is on the ESP32, indicating that it's talking to ROS2 running in the Docker container. And then it's got one of these Nito style LiDARs. I've got the motors disassembled off because I was trying to figure out what was wrong. So anyway, I ordered a new motor. New motor came today, and I mounted it, and the darn thing won't move. So I was like, that's very disappointing. I was hoping to be able to show it navigating around, but I realized I can actually show it on RViz. So let me.
So do you think the motor driver is bad, or just
no? Because it's not the motor driver; it's the motor. Because I swapped the motors across to the other side, and
so you got two bad motors then, I guess.
I got two bad motors from them. So I'm like kind of annoyed about that. So I think, are y'all seeing? Let's see.
I'm seeing infinite address.
I think I've got the wrong screen shared. Let me just start presenting and present a window. This one. Okay, so are you all seeing the RViz window here?
Yes.
Yes.
Okay, so this is the LiDAR sensor output. So I'll just sit the LiDAR up on top there, and zoom in on the robot. And so this flat piece along here is the screen, is the monitor, the face of the monitor. And if I turn the LiDAR around, it rotates a little bit. And then this is my hand, and this is my body. Let's see, this section is my body. So I brought this up by turning on SLAM. So like further away from the LiDAR is, let's see, what direction is stuff in?
To your right, maybe?
Yeah, I'm not sure which. Oh, there's the glass. Let me move the glass out of the way. Trying to orient. Maybe it's not picking up the glass. Anyway, just to say, or just to show that the LiDAR is actually talking, sending data over Wi-Fi from the via the ESP32 up to a Docker container running ROS, and I'm running RBIZ out of the Docker container, and it's running the ROS SLAM code, so it's capable of creating a map. So anyway, that's what I had to show. It's some progress.
Yeah.
I'm still very disappointed about having dead motors, but there you go.
Did you just have you put just DC voltage on the motors and see if they move? Or?
Yeah, that's my next thing to do, and I only just really discovered that the motor was dead this evening, right before the meeting. when I was trying to make it work. So not enough time to recover and do a diagnostic test. But yeah, when I I hooked it all up, and one motor ran and the other one didn't, and then I felt the one that wasn't moving and it was hot, and I was like, that's not good. So turned off the power and tried a few more times and determined that that one motor was just didn't want to run, even if I gave it a little nudge. And so then I swapped the motors over onto the other connectors, and the other motor that was running ran on the dead motor's connector. So it's got to be the motor. Just won't run.
So what's the gear ratio? Or
I don't know. They're
must be pretty high, like
they're
500
motors.
Okay.
N20 is the number on them. And so this black thing at the end of it is the magnet that runs the encoder, and then it's got some Hall effects sensors on a little PCB at the back end of the motor, and then it's got this gearbox on the front end, and it runs at I believe it's rated at 150 RPM on the output shaft, but I don't know what the gear ratio is. So what speed the motor is running at. So anyway,
can you rotate the magnet on the back to see if the motor shaft is locked?
Yeah, I did, and I can rotate the motor on the back, and the wheel spins, the output shaft spins. So the gear train is connected, but the motor won't run for some reason. So I'm very disappointed about two dead motors. But
I wonder if it fried the brushes, or they maybe made a burn spot on the commutator or something. Could have.
I wonder.
Especially if it got warm. So.
Yeah. Oh, that's a thought.
Yeah. I don't know if you can see in. It might be a sealed motor, but.
Yeah, it's sealed. I mean, and it's so tiny. I mean, the thing's minute. I don't think I want to like pull that apart. I just want a working motor.
Don't
suppose anyone has any N20 motors in their box of parts.
Nope. Did you give it the sniff test? Does it smell burnt?
No, that's a good thought. Neither really smells.
No detectable crispy components or anything.
This one might have a little bit of a smell. This is the one that won't run. Yeah, that one's got a little bit of a burnt smell, so maybe it fried the coil.
Maybe, yeah.
This one I'm pretty sure, the one that sticks, I'm pretty sure is a mechanical problem. Because let me share a little video that makes me believe that. Photos. Okay, and put this up. Okay, so just figure out how to share this. Share a window.
You can get those from $10 each from Amazon.
From Amazon?
Mm-hmm.
Oh, really?
You just got to know which gear ratio you have.
Oh, okay. Well, thanks. Well, that's better than like $14, including shipping from the robot vendor.
Yeah, if you've actually got prime.
Does it have the same encoder on the back, though? Could that be an issue?
It might not be identical. This one's a wave share that I'm looking at.
If you wouldn't mind posting a link to that, Kareem, that'd be great. So here's the video that makes me think that the motor is bad. Are you all seeing the video? Okay. So you can see the other one's running, but then you can just touch the magnet and it like starts and stops. So it's got some kind of stiction issue, or I don't know what. But anyway.
What if you do it at the other end? Like stop the wheel.
I didn't try that because it's got a pretty, I mean, it's a pretty big gear ratio because it's really hard to turn, to get the motor to spin by turning the wheel, and I didn't want to put too much force on it.
Oops. Oh.
So anyway, that's what I got.
Well, I don't know. Yeah, I would not do it at the encoder level because you're at risk of spinning the the magnet on the shaft and loosening that up.
Oh. Okay. So I'm turning the power off to this thing off. Oops. Okay. Anyone else got anything? If not, maybe it's that time. Oh, perfect. Thanks for the link, Kareem.
Sure.
All right. What do you think? Shall we have we reached the end of the meeting?
I'm good.
All right. Thanks, everyone. Good to see you all.
Thanks.
See you
Bye.
Saturday.
See you Saturday.